Welcome back to Math 99 Week 4 lectures. Remember again, you do have quizzes due this week. Make sure you check your course outline for dates and appropriate quizzes. So we were talking about exponents and powers, and we want to finish up this week talking about polynomials. There's a couple of definitions you should know. So let's start with a term. A term is just a number or the product of a number and variables. So we can have simply a number, or we could have the product of a number and variables. Remember that product means multiplication. We're going to be doing a lot of work with polynomials this semester. A polynomial is a finite sum of terms. Finite means there's an end to the number of terms. It's not infinite. So if we're talking about a monomial, this is a polynomial with one term. For example, 9x cubed. A binomial is a polynomial with two terms. 9x cubed minus 4x. A trinomial is a polynomial with three terms. So notice, even though we say that a polynomial is a sum of terms, I have subtraction in there, because if we were to write 9x cubed plus negative 4x, we already know from our discussions about adding and subtracting with signed numbers that that plus minus beside each other can be written simply as a minus sign. One of the things that's going to be important, especially in Math 103, is to remember what the degree of a polynomial is. Now, the degree of a polynomial is always the highest power on a variable. We're talking about polynomials with one variable. If there's more than one variable in a polynomial, the definition's a little bit different, but we're not going to be looking at the degree of those types of polynomials. So if you look at my example here, we have a polynomial of three terms. So we know that this is a trinomial. What is the degree? Well, the degree, again, is that highest exponent. It has a degree of 3. Let's talk about adding and subtracting with polynomials. This is just going to add to what we were already saying when we were talking about adding and subtracting like terms. Remember that like terms are terms that have exactly the same variables raised to the same exponents. And we're going to do the same thing we did earlier. We're going to keep the variable and its power, and we're only going to add and subtract the coefficients. So here I have a trinomial plus a trinomial. When we are adding, we can simply open the brackets. So we have 2x squared minus 7x plus 5. There's this plus minus here, but adding doesn't change anything. So I can just write minus 3x squared plus 7x plus 5. Now remember, when you're adding and subtracting, we're only adding and subtracting like terms. We could rewrite this so that our like terms are next to each other. This isn't necessary, but it might make it easier to look at. So I notice I have 2x squared minus 3x squared. And then I have minus 7x plus 7x. And finally, plus 5 plus 5. So now my like terms are beside each other. We keep the variable raised to its power, and we add and subtract the coefficients. 2 minus 3 is negative 1. Negative 7x plus 7x, well, if I keep the x, negative 7 plus 7 is 0. I don't need to write 0x. That means I don't have any x's. Plus 5 is plus 10. This is where it gets a little more interesting when we're subtracting. So of course, on your final exam, even on your tests, I'm going to give you a subtraction question rather than an addition question. When we're subtracting, when we open the brackets, we're going to change the signs in the second bracket. So the first bracket stays the same, 2x squared minus 7x plus 5. But if you think of that as a negative 1 multiplying across the bracket using the distributive property, we're going to have plus 3x squared minus 7x minus 5. Notice that I changed all of the signs in the second bracket. And now we combine like terms again. You don't have to write your terms that are like together. I'm just doing it so we can see it more easily. Remember that you keep the variable and its exponent. 2 plus 3 is 5. Keep the x, negative 7 minus 7, minus 14x. Plus 5 minus 5 is 0, and I don't need to write plus 0. I have two more examples here of adding and subtracting. These are known as vertical addition and vertical subtraction. The reason it's nice to do these questions vertically is that we already have our like terms lined up. It makes it really easy to see what we should be adding and subtracting. So the first one, I can just go ahead. 4x squared plus 2x squared is 6. Keep the variable and its exponent. 3x minus 3x is 0. I don't need to write that there. Negative 2 plus 4 is plus 2. But this is the one that we are especially interested in, and this is the one you need to practice, because when we get to polynomial long division, we're going to be doing a lot of vertical subtraction, and it's the place that most people make a mistake. It might be easier to rewrite this question, opening the brackets and changing the signs in the second bracket. So I have 4x squared plus 3x minus 2. When I open the brackets, I get rid of that minus sign, but I multiply it through. So now I have minus 2x squared plus 3x minus 4. Once I've opened the brackets, all I have to do is combine like terms or add. 4x squared minus 2x squared will be 2x squared. 3x plus 3x is 6x. Negative 2 minus 4 is minus 6. Let's look at this again, because when we're doing long division, we're not going to want to rewrite things. We don't have space for that. So we want to just think about what's happening. 4x squared minus 2x squared is 2x squared. 3x subtract negative 3x. That subtract negative, that's plus. So 3x plus 3x. Negative 2 minus positive 4, that's just going to be minus 4. Negative 2 minus 4 is negative 6. Please be sure you practice these vertical subtraction questions. When you're looking at the examples in the homework where you can do a similar question, make sure you do a couple of them, or look in your e-text to find some examples of vertical subtraction. Now we want to use those exponent rules when we look at multiplying polynomials. We said in the earlier lecture that we keep the base and add the exponents. I asked you to go home and memorize that rule, so I hope you've done so. When we're multiplying a monomial times a monomial, that means there's no adding and subtracting. This is just one term. I have 2x cubed times 3x squared. Remember that multiplication is commutative. I can change the order of this question. I could write this as 2 times 3 times x cubed times x squared. We were looking at examples like this. You multiply the integers in front, and then you multiply powers with the same base. Keep the base, add the exponents. Pause your video and try the next 3 questions. Here, we're using brackets to represent multiplication. Remember, we multiply the integers in front, negative 4 times 2. Keep the base, add the exponents. This next question is still multiplication. We have 5 times negative 5 times 2, negative 50. Keep the base and add the exponents. 2 plus 2 plus 1, 5. Multiply the integers in front. 2 times 3 times negative 1. And then we're going to multiply powers with the same base. So we have m. We also have another base, n. Let's start with m. Add the exponents. 3 plus 1 plus 2. And then n, add the exponents. 2 plus 2 plus 3. Nothing different there from what we did in our last lecture. But now we want to talk about a monomial times a polynomial. Notice that inside my polynomial, it means I have addition and subtraction. A polynomial has more than one term. And if I think about order of operations, I can't simplify inside that bracket. B plus C, these are not like terms. They can't be combined any further. So we're going to use the distributive property. The distributive property says if there's adding and subtracting inside the brackets and you cannot simplify it any further, you need to distribute that A to every term inside the brackets. And so we have A times B plus A times C. Let's practice some multiplying. We start with 3x times 2x. Well, we know we multiply the integers in front, 3 times 2, and then add the exponents. And then 3x times 5. 3 times 5 is 15, positive 15, and there's only one x. Why don't you pause your video and try multiplying the next two? I find that sometimes people forget to multiply all the way through, and so using the arrows is helpful, especially when you're learning. -4 times -5 will be positive. When we open the brackets, we multiply every term by the monomial outside the brackets. Let's talk about multiplying a binomial times a polynomial. Now, if you see these first examples, they're a binomial, 2 terms, multiplying a binomial. So I have 2 terms times 2 terms. What you need to remember is that the first term multiplies the second bracket, and the second term multiplies the second bracket. So we have x times x plus 4, and then plus 3. Now let me be really clear about that because people make a small mistake here. This is a plus 3, so you have to write a plus 3 here, times the second bracket. X times the second bracket plus 3 times the second bracket. Now we just open the brackets using that distributive property again. X times x, x times 4. Notice I write the number in front. We always write our numbers, our integers, and our rational fractions in the front of the variable. And then plus 3x plus 12. Don't forget those plus and minus signs in front of your numbers. Now we have a polynomial with 4 terms, but I hope you notice that there are like terms here. We need to simplify by combining like terms. Try writing the first step in the next multiplication question. 3b squared times the second bracket plus 7 times the second bracket. Did you get there? All right, pause your video and see if you can complete this question. We don't have any like terms here. We're finished with this one. Now we have a binomial times a trinomial. Why don't you pause your video, try writing out the first line. X times the second bracket minus 3 times the second bracket. Why don't you pause the video and see if you can finish this? We're using the distributive property to open our brackets. Now we're multiplying by -3. And I do see like terms here that have to be simplified. So we only have 1x cubed, but 4x squared minus 3x squared, that's going to be plus 1x squared. -3x minus 12x minus 15x, and then plus 9. Did you get that one? If you didn't, you might want to come back to it later and try it again. There is always on the final exam a question asking you to multiply a polynomial by a polynomial. Many terms times many terms. In this case, a trinomial multiplying a trinomial. Every term in the first bracket has to multiply the second bracket. Actually, I'm going to write that down here where I have a bit more room. 2x squared times the second bracket minus 5x times the second bracket plus 2 times the second bracket. And I'm just going to move my equal sign to the front of all of this. Okay. Why don't you pause your video and see if you can finish it? Use the distributive property to open the brackets. Did I make a mistake here? I did. Did you guys catch that? Minus 5x times x squared. Wow, I don't know what I was doing. Minus 5x cubed minus 20x squared plus 15x. You're going to have to really speak loudly for me to hear you when I make mistakes. Okay, let's see if I can combine like terms. I know there's only one x to the power of 4, but let me highlight all of my x cubeds. So 8x cubed minus 5x cubed plus 3x cubed. Let's find the x squareds. -6 minus 20 is -26 plus 2, -24 x squared. I also have powers of x to the power of 1. 15x plus 8x plus 23x, and then minus 6. You see, it's so possible to make mistakes in all of this. So take your time, go back and check, practice. It should be okay. Now, at the end of this page here, I have some questions for you to practice, or sorry, at the end of the notes here, I have some questions for you to practice. These are the kinds of questions that will be on your test, on your final exam. I'm not sure about this. In fact, I hope I've taken those out of your notes because I know we're using a new textbook, a new edition. If you have any questions, make sure you meet with me on Thursday and I'll help you then.